Hello guys, so welcome to your Python programming tutorial videos. This is our 10th video and I'm trying to explain to you guys how to program in Python via very short videos. I'm trying to be descriptive as much as possible, and I hope you guys understand these videos. So in this video, we are going to be looking at understanding mutability, immutability, and the garbage collector. Now, these are terms in Python you're going to hear a lot if you go through a Python book or if you study Python online. Now, in the last video, we studied how Python saves objects in memory when you create a variable. And in this video, we are going to somehow continue from that video. But in this case, we are going to be looking at it from a different point of view. That's in Python, when a value of an object cannot be changed, we say that the object is immutable, while objects whose value can be changed are known as mutable, are known as mutable, while objects whose values can be changed are known as mutable, while objects whose values cannot be changed are known as immutable. Let me put it that way. So mutable is when the value can be changed. I guess this is a mistake here, sorry. So while immutable is when the value of the object cannot be changed in memory. So in Python, numbers, floats, and complex strings, boolean, and tuples are all immutable, while list, dictionary, and sets are mutable. Now, for example, we are going to see these are immutable data structures. So we have numbers, we have this is a float, this is a complex number, here is a string, here is a boolean, and here we have what we call a tuple. So these data types are normally immutable. So as you can see, I've printed them out. You can see these are them. I use the type operator to print out the type of the variables, not just the variables, but the type. So as you can see, the first one is an integer, second one float, complex, string, boolean, tuple. All right, now, mutable data structure. These are mutable data structure. These ones you can change their value in memory. Normally behind the scenes they're somehow immutable, but from a broad point of view, they are mutable. It means their value can be changed. We are going to learn all these data structures in separate video. I'm going to teach you guys lists, tuples, strings, numbers, and we are going to learn all of them in full details. But in this video, I'm just trying to show you what mutability and immutability is. So let's look at this now. All right, so here is what we call a list. I'm going to show you guys that later on. Here is a dictionary, and here is a set. So these types are, as you can see, list, dictionary, set. I'm printing out that type here. You see, these are what we call mutable data sets. Now we are going to look at that later. Now let's see what the garbage collector is all about. Now we created a variable 30. What happens is Python is going to create an object and assign it a value 30 and assign it a type integer, because Python realizes this does not have a decimal point. And here Python will create another object. It has a reference count of 1 from the previous video. We learned about that. Here Python is going to create an object with value 40, reference count 1, type integer. Yeah, Python is going to create another one, another variable string with the value hello and with the reference count 1. Now you see this variable, now we assigned it a different string. Now because a string is immutable, what Python is going to do is to create a totally new object. It's not going to change this value here to stop. No, this memory is going to be abandoned. Value now is going to point to a different location in memory with a different string stop. You understand? So this object now is not going to have any pointer, so its reference count is going to be 0. Now this one is going to have a reference count of 1. Now take note, if we say speed is equals to 40, Python already created an object in memory with the value 40. So Python is going to point speed to that same object in memory and give it a reference count of 2. So now this object which has 40 as a value is going to have a reference count of 2. Now we have score equals to 30. Now Python already has value equals to 30. So it's going to point this to that same object, and you're going to see it having a reference count of 2. Now if we print out the memory locations of this, you can see this memory location is the same as this memory location. Why? Because score and value point to the same object, while this memory location and let's say this mark and speed point to the same object in memory. Python does not create duplicate object. Now like I explained, this memory location is going to be empty. Is going to be empty because the reference count now is 0, and if no value is assigned to it, Python is going to wipe it out of memory. That's called garbage collection. When Python wipes an object out of memory, it's going to be called garbage collected. Now, Python does that only when an object has a reference count of 0. Maybe the identifier that created it now points to a different object. So once an object stays in memory with a reference count of 0 for too long, Python is going to garbage collect it. It's going to remove it from memory. Here's an example. We have var130. You can see Python creates an object int reference count 1. We have var2 40.5. Python creates another object, you see 40.5, and you see now we have var3 true. We have here Python creates a boolean. We have var5, var4 hello. Python creates it. We have var5 30. Python now already has 30 in memory, so it's going to point var5 to that object. It's going to now have a reference count of 2. var6 30. Python is going to point it to that object and it's going to have a reference count of 3. So let's look at this now. When we say var1 equals to 10.2, Python is going to cut that pointer from the original object to a new object, because Python can't change this object in memory since it's immutable. Since it's immutable, Python can change it. Now var5 is 2000. Python is going to cancel it from the original location to a new location, which has that's let's say var5 2000 to a new memory location. Now var2 John, Python is going to point John, that's var2 to a new location John. Now var3 40.5, var3 40.5, Python is going to point it to a new memory location, and var4 10.2. 10.2 already exists in memory here, so Python is going to point to 10.2 here, as you can see. So 10.2 now is going to have a reference count of 2. Python will not create a new object because it already has an object with a value 10.2. Yeah, so that's how it works. So as you can see, what happens in memory is that, for a summary, once Python wants to create objects in memory, if you assign a value to an object that already exists, Python is going to point your identifier to that object and then increase the reference count of that object, so that you know that Python is going to increase the reference count of that object. Now, if an object is in memory for a long time and it has no pointer, Python is going to add garbage collect it. Python is going to delete it from memory, and a garbage collector is going to pass through that object and delete it out of memory. So, but if you assign a value later to that same object, Python is going to point back to that object. So when an object stays in memory for long with a reference count of 0, it's going to be deleted from memory. All right, so I hope you've understand the meaning of mutable, which means an object's value can be changed. Immutability, its value cannot be changed. And garbage collected, which means when an object remains in memory for long with a reference count of 0, it's going to be wiped from memory. All right, have a nice time and see you in the next video. Thanks.